Let's look at the question, largest component size by common factor. We are given an integer array of unique positive integer names, and we should consider the following graph. There are lengths of names nodes labeled from names at 0 to names at lengths of names minus 1. If names at I and names at j share a common factor greater than 1, then there is an undirected edge between the names at I and names at j, and we should return the size of largest connected component in this graph. For example, in the given input, we have names which is 2, 3, 6, 7, 4, 12, 21, and 39. So this graph will be constructed as follows. There is an edge between 2 and 6, 4 and 12. So because 2 and 6 share a common factor of 2, and 4 and 12 share a common factor of 4. And there's an edge between 3 and 6, because 3 and 6 share a common factor of 3. And there's an edge between 7, 21, and 39, because 7 and 21 share a common factor of 7, and same for the 21 and 39. And 2 and 3 are prime, so it doesn't have any common factor with others. So the largest connected component in this graph is 8, because it has 8 integers. All of them are in the same component and share a common factor greater than 1. We could consider this problem as a graph partition problem. So each number represents a node in a graph, and we are asked to partition the nodes into several groups and find the largest one. So suppose that we have a means to determine and assign each node to a proper group. Then we could easily solve this problem with just a single iteration. Literally, we just count the appearance of each group. First, we initialize the empty dictionary group count to store the count of each group of integer, and we use a for loop to iterate through each integer in the number list and calls the group function on it to determine the group ID of the integer, and then we update the count of the group in the group count dictionary. We increment 1 for the value which is associated with the group ID, and finally we just return the maximum value from the values in the group count, which is the size of the largest connected component in this graph. The key to the above algorithm lies in question how we define a group and how we assign an element to a group. So given the above intuition, it might remind you one of the most well-known data structure in computer science, which is called disjoint set, which will track a set of element partitioned into a number of disjoint subsets, and all of them is no overlapping. Indeed, the disjoint set data structure would be the essential building block to solve this problem. The disjoint set data structure is known as the union find data structure because it mainly consists of two operations, union and find. Define as the find x function will help us to get the identity of the group that element x belongs to, and the union x and y function will merge the two groups that two elements belong to respectively. First, we define a Python class disjoint set union. A class is a blueprint for creating object and providing initial value for state, which is member variables or attributes, and implementations of behavior, which is member function or methods. So the object in the class definition is a base class in Python, and it is used to indicate that the class definition should inherit from it. So this is commonly used in Python to create classes that inherit from existing class. So in this case, the disjoint set union is a subclass of the object. After we create an object of the class, then we try to initialize the state of the object. You take a single argument site, and we initialize the parent attribute of the object. So the parent attribute is a list that stores the parent nodes of each node in the disjoint set union. Initially, each node is an independent component, so the parent of each node is set to itself. So this is accomplished by using a list comprehension, which generates a list 0, 1, 2, 3 until size -1, and we assign it to the parent attribute. And the size attribute is another attribute of disjoint set union object, which keeps track of the size of each component. Initially, it is a list size +1 once, which means that initially each component has only one node inside it, and the list generates a list of size +1 once. The find method is used to determine which component an element x belongs to. So this method takes a single argument x, which is the node that you want to find a component for, and it returns the parent of x, which is the ID of the component that x belongs to. So this method first checks if a parent of x is equal to x itself. If so, it means that x is the root node of its components, and the component ID is simply just x, right? And if x is not the root node, then the method recursively calls itself with the parent x as its argument until it will find the root node, which will set the parent of x to be the result of the recursive call and to find the parent of x as the argument. The union method is used to merge two components that node x and node y belongs to respectively. So this method takes two arguments, x and y, which are the two nodes that we want to merge. So the first step of the union method is to determine the component ID of the node x and node y by using the find method. This is done by calling the find twice, and once for x and once for y, and then we just store the result in px and py respectively. Now let's implement the merging of the two components. We just assign py become the parent of px. So the parent of the small component indexed by px is said to be the parent of the larger component indexed by py. And then the size of the larger component is updated to include the size of the small component by adding the size of the px to the size of the py. So this can ensure that the size of the larger component will reflect the combined size of the both components. After we find the components IDs, and then we check if the px and py are equal, which means if the nodes x and nodes y belong to the same component. If so, that means we have to directly return the components ID without doing anything because they belong to the same group. So if px and py are different, that means the node x and node y belong to the different components, right? So in that time, we have to merge the two components. So to do this, we have to first check which component is larger. So based on the size we store in the self.size, if the component that px belongs to is larger, at that time we just swap the px and py, so that the py is the index of the small component. So this will ensure that the smaller component will be added to the larger component.